All right. Hey guys, so it's 1:35, so let's go ahead and get started. We're gonna try today to makeshift some graphs, okay, just in your notebooks, because that's what we're getting into, and I want you to have examples to look off of, and we're just gonna kind of see how it goes. So last class we focused on discrete, okay, discrete being our dots, just numbers, and writing out what that domain and range looked like. I'm pretty pleased with what I saw for that homework assignment. It seems like as long as you were here for the notes and took the notes, the homework was really easy. I had lots of 30 out of 30, so that is awesome. Those are not in the grade book yet, but hopefully by the end of this week. There's another type of graph that we need to talk about. So again, last class was discrete. So we were looking at graphs that were just a bunch of dots, or they were a set of ordered pairs. Well, today, continuous, we're gonna look at line graphs, okay? And these lines are gonna be all different types. We're gonna look at 6 graphs, look at the domain, the range, and whether it's a function or not. So here's your header for your notes today. And graph 1, or example 1, we're gonna draw in the XY coordinate plane. Okay, so you're just gonna kind of sketch some graphs for me. I know you don't have graph paper, you're just getting an idea of what this looks like. And I need you to draw me a diagonal line with arrows in this vicinity. Okay. So this is continuous because it's a line. Okay, anything that's going on my paper should be going in your notebooks. And so when you have a continuous graph, we are going to set up the domain like this. I'm going to put a number in this blank, less than X, less than a number here. This is the format that we're going to keep using today, as long as it's a continuous graph. Now my x-axis goes left to right. The domain is the x values. So I'm gonna put a left number here and the number on the right side of my graph here. And my thought is, guys, let me get through 2 examples and then kind of start asking questions. It's gonna seem weird, but the more we do it, the easier it's gonna. Okay. So the left part of my graph is here. This arrow means my graph's gonna keep going to all the way to infinity, but my X numbers are getting smaller. So my left number, this graph, is going to negative infinity along the x-axis. The right side of the graph is here, but it doesn't stop here. It has an arrow. So my line's gonna keep going to positive infinity to meet Buzz Lightyear. Here's my domain. Okay. Let's take a look at the range. We said it was continuous, so if it's continuous, I'm gonna set up my range like this, because then all I have to do is fill in the blanks. Range is the y values. The y-axis goes up and down. So I'm gonna look for the bottom of my graph, and then I'm gonna look at the top of my graph. By graph though, guys, we're looking at the line. So the bottom of my line is down here, but it's not stopping here. It has an arrow, it's gonna keep going to negative infinity. The top part of my graph is up here. This is the top of my line, but it's not stopping here. It has an arrow, it's gonna keep going to positive infinity. I know this seems kind of weird. Let me go over another example where we're not using infinity, and we'll see if that kind of helps start making this make sense. So hang in there with me. Okay, I know this seems kind of weird. I promise it's going to get easier as long as you're trying and you're paying attention. Our second example. Draw in your x-axis and your y-axis for me. And I want you to draw me a circle. Okay, make it a pretty big circle. On this circle, on your paper, I want you to put a 1 inside of it. And at the edge of your circle, I want you to put a 2. On this side, I want you to put a -1 and a -2 inside your circle. And on the edge of the circle, I want you to put a -3. Okay, we're labeling our x values. Here, I want you to put -1 inside the circle on the y-axis. And the edge of your circle should be at -2. Going up the y-axis, I want you to put 1 and 2 inside your circle. And 3 is where I want you to touch the top of your circle. This is kind of the best that I can do right now since I can't give you guys paper and I don't know if you have graph paper. So these numbers, this is just setting up our graph so we know what numbers to look at. This is still a line, okay? I know it's a circle, but this is still a line. This does not look like a bunch of dots. So this is a continuous graph. Because it has a line on it. Okay, you are going to need to know the difference between continuous and discrete. So my domain is
what does
continuous.
discrete look like?
Discrete is made up of dots. That's what we were doing last class.
Oh, those are not dots.
These are just really bad dots. This is a line. So continuous has a line.
Oh, they actually have coordinates.
No. So continuous, we're going to set up using that inequality. Okay, domain is x, so I'm going to put x in the middle. Again, make sure you're taking these notes with me. So domain is going to be left to right. So the left part of my graph is over here at -3. Okay, so -3 in this blank. The right part of my graph is over here. And that x value is at 2. So I'm going to put a 2 here. Okay, so sometimes we're using infinity if there's arrows involved. Here, there are no arrows, so we get to use actual numbers. When we use actual numbers, we're going to turn these into less than or equal to. Okay, we can't equal infinity, but we can equal -3. We can equal 2. So that's what that difference is. Okay. Let's take a look at the range. So I'm going to fill in a number less than y, less than a number. Y goes up and down. So I'm going to put my smaller number in the bottom number, and then I'm going to put my top number in. The bottom of my graph is at -2 for the y value. So I'm going to put -2 in this blank. Since it's a number, I'm going to turn this from less than into less than or equal to. Top part of my graph is up here. That y value is at 3. So I'm going to put a 3 in this blank. I can equal 3. I'm going to change this to a less than or equal to. So that's kind of where we're headed. Ask me again.
He said it was easy.
Oh, cool.
Is this how will we have to, like, in the next one, will we have to, like, solve it?
So all you're gonna have to do today is look at a picture and tell me what numbers. You don't have to solve anything.
Okay.
Let's try another one. So my thought is I'm gonna walk through one more and then I'm gonna attempt to have you guys try some. So our next graph that I want you to sketch. We're gonna draw on the X and the Y axis. And we're gonna go ahead and put some numbers on our graph as well. So this is 1 and 2. This is -1, -2. -1, -2. 1 and 2. Okay, so that's just setting up my XY coordinate plane. My graph, I'm gonna put a dot here and I'm gonna draw my line going like that. So sketch that graph for me the best that you can in your notebook. Okay. Is this graph discrete or continuous? Type your answer in chat for me. Discrete or continuous? You can even just type in a D or a C for all I care right now. Okay. Awesome for those of you participating. It's a line, so it's going to be discrete. Just kidding. It's a line, it's going to be continuous, like what you guys told me. Sorry. Okay. It's not a bunch of dots. So this has a dot, but that line overrides the dot. So if there's any sort of line, it's going to be continuous. If it is just dots, that's when it's going to be discrete. So since it is continuous, that means we can go ahead and set up our inequalities. So my domain, I need to fill in a number, less than X, less than fill in a number. Domain, the x-axis goes left to right, so I need to fill in the left number and then the right number. The left part of my graph, my line stops here and it's got a dot, it doesn't have an arrow. So my left is at 0. It's a number, we can use it. The right part of my line is here, but there's an arrow.
I have a question.
It's not gonna stop, it's gonna go to positive infinity. Yes, what is the question?
So wherever the wherever the line begins is the left domain, right?
Yes, the furthest left part of the graph, whether it starts here, whether
I
it's
was gonna ask that question.
part, yes. Other questions that I can answer right now. That's perfect though, guys. So if you have a question while it comes up, just ask me. Okay, unmute yourself and ask. Hey, it's a number. So we want to go ahead and make this equal to. And now we want to go ahead and we want to find the range. So my,
How would,
Mhm.
oh, how would the right side be infinite?
Because there's an arrow. So this line's gonna keep going on forever.
Okay.
And these X values are getting bigger.
Wait, how'd you get 0?
So can somebody explain that? How did we end up with 0 for the left?
Because that's where the first dot starts.
Because there's no part of the line after this. Yeah, it just starts right here. This is the left part of the graph
So does that work every time?
of like where the graph starts, you mean?
Yeah, like wherever the like line starts. Like let's
Yes
say if
and
it started on 1, would the domain still be 1?
yes. Now do
Right.
be careful though, because like here, the line doesn't start here because there's an arrow. So you would just have to be careful whether it's actually starting or whether it's continuing to positive or negative infinity.
All right.
We'll do a couple practices where it's a little bit of everything, and hopefully the more we practice, guys, the more sense it'll make. But keep those questions coming. These are great questions. Okay, so let's take a look at the range. Okay, we did the X's, so now let's look at the Y's. So range is gonna go bottom to top because we're always gonna put our smaller number first. And so where's the bottom of my graph?
The negative.
Is it where that dot is?
It's actually where the dot is at. So it's not negative because it starts here. So what Y value
So it's
is
like
that?
0,
Yep.
Oh.
0.
Okay. So not only is this the left part of my graph, but it's also the bottom part of my graph. Okay. And so the top part of my graph is also up here where the right part of the graph was. So this
So
is
we-
also going to go to infinity.
How? How?
I'm actually starting to understand this.
Same.
So I think
But you
what we'll
said-
do, I'll do one more example with you guys that has more of a left and a right side, top and a bottom, versus kind of here. There are only 2 parts to look at. So I'll give you another graph where there are kind of 4 different parts to look at and see if that clears up confusion. And then I'll give you guys 2 to try on your own. Does
Wait, so
anybody-
The first sign.
Go ahead, Jay.
anytime the range has a line, it will be for the top it will be infinite.
If there's an arrow,
Oh,
it depends on whether there's an arrow. Like this is gonna keep going up, and so it's gonna go up to infinity.
okay.
Range, would the first inequality have an equal to sign as well?
Yes, it's a number, so we need to change that to equal to. That's what you were looking at, right, Ms. Lookout? Yes, you are correct. Thank you. All right.
Wow.
So let's try another one.
Okay.
So draw your X and your Y for me. And we're gonna put some numbers on the graph as well. Give me a thumbs up when you've got all of your graph written down. Please. Thanks, Jasleen. Thanks, Jonathan. Okay, give me a thumbs up if you've got all this written down for your graph. Thanks, Ida. All right, Adrian. Thanks, Jay. Thanks, Kirat.
Wait, on our worksheet, are we gonna have to put the greater or equal sign too? The greater than or equal to sign?
You mean when you're doing Schoology?
Yeah.
I am still figuring that out. So it might be one where if I have you do that, it'll be like your test where you would just type it in like this.
Oh, all right.
your X, and then it would look like that. So
Okay.
that's how I would
Okay.
type it in. Awesome. So let's go ahead, let's draw this graph in. So our graph is gonna have a point at -1, 1. And then it's gonna go up and it's gonna go up. That is kind of lopsided. Hopefully your graph looks better. Okay, so a point at -1, 1, and then it's opening up. We've got a line, so we know this is gonna be continuous. And if it's continuous, just go ahead and set up that inequality for me. Okay, and we're just gonna fill in the blanks. So domain is X, left to right. So on here, the left part of my graph, so it doesn't stop.
Will it be -1?
So it goes past that. I still have line over here. So the left part of my graph is the furthest part of the line that's on the left. So it kind of looks like it's at -2, but is my line stopping at -2?
No.
Because it's got the arrow, right? So this arrow means my graph's just gonna keep going and going, but are my X values getting bigger or smaller?
Bigger.
Smaller.
My X values are getting smaller because I'm going this way. So my left value is going to be -infinity.
Mm.
Okay, because I gotta look at the furthest left part of my graph. So what about the right? The furthest most right part of my graph, it's not here. My graph goes all the way over here on the right side.
So it's infinity.
So it's infinity because we have an arrow. And are these X values getting bigger or smaller?
Bigger.
Bigger. So this is gonna go to
Bigger.
positive infinity.
It's good.
My domain's not gonna look like this though. Oh my gosh, I can't talk to you guys at all today. Domain should look like this because that's what we just wrote down. The range will not look like this. Okay, my range, let's set up our Y values. So I'm gonna go from bottom to top. So where is the bottom of my graph?
1.
-2.
-2.
Where's the bottom of the line? So not necessarily the graph. There's no line down here. Where does the bottom of my line hit?
-1.
Yeah,
Okay.
-1.
But we're looking at the Y, so we need to look at the Y value. So it would be, okay, so it's gonna be 1 because I'm looking at my line and the bottom part of my line is at 1. The top part of my line. So the top part of my line, it doesn't stop at 2. My lines keep going to positive
Infinite.
infinity. So let's talk about, go ahead, ask your question. Let's talk about what if you get infinity for an answer in Schoology? How can you type that in? I put this in writing for you guys, but what you would do is you would just write out the word infinity into the blank for Schoology, right? Or if it's negative infinity, you would write out the word negative infinity. So that's what it would look like on Schoology is you would just type the words out and I've got the spelling for you written down within the question. So just kind of an FYI for later when you're doing your assignment.
Okay.
All right, so I want you guys to try one. We're gonna see how this goes. And then we've got one more kind of vocab word that we need to talk about, but I want you guys to try one. So let's do this. So here's my graph. Here's 1, here's 2, -1, -2, 1, 2, -1, -2. Give me a thumbs up when you've got all this written down for me. Awesome. Cool. Okay. So this graph, we're going to put a point at 0, 0. And then we're going to draw a curved line going this way and going this way. I want you guys to try to find the domain for me.
What's going on in here?
Okay, it's a continuous graph, so we're going to use the inequality. So what would my domain look like? Give me a number, give me a less than or equal to, x less than, or equal to, and then a number. So give me the entire thing. What would my domain be?
Do you want in the chat?
Yes, please. And if you're not sure, now is a great time to be asking a question.
So you just want the domain right now, or the
Yep.
range?
Yep, just the domain.
Okay.
Thanks, Christian. Thanks, Rochelle.
For the bottom one on example 4, do we need a underline? Yeah,
Yep, it's a number. I just keep forgetting.
you're fine. I'm writing the notes too and adding little details for the kids. So
Perfect.
I was gonna write a number, like always do equal.
I'm seeing really good stuff, guys. Awesome. I wasn't sure how this was gonna go, but those of you paying attention, participating, or you're all cheating really well, but I'm gonna have faith in you guys. Awesome. Okay. Left starts at 0. And Nick, I would take your answer written like that. It's a number, so it's gonna be equal to, and I love how many of you paid attention to that small detail when you sent it to me in chat. And then it keeps going on the right side, all the way to infinity. So there's my domain. Find the range for me.
So whenever it's a number, you have to put equal to.
I'm gonna write that.
And yes, if you have an open dot, like last chapter when we were solving inequalities, if it was greater than or less than on a number line, it was an open dot. So if you had a graph that looked like this and it was an open dot instead of a closed dot, you would not put equal to.
Oh, all right.
Most of the time, I'm always going to give you a closed dot. So 90% of the time, yes, always put an equal to, but this would be the exception.
All right.
Okay. Make sure, so I gave you guys this one on purpose. Make sure you're looking bottom to top. I've got people close, but I don't think anybody has the correct answer yet. We're looking at range. So make sure you're also using a Y, guys. Range is Y. Okay. About 30 more seconds. I want to see what you guys come up with, and then we're going to talk about it. All right, so the bottom of my graph, guys, this isn't the bottom of my graph. My graph doesn't stop at 0. The bottom of my line is down here, but it's also not stopping at -1. This is gonna keep going. And so this actually goes to negative infinity. This dot is not the end of my graph. This is not the bottom. My bottom is all the way down here.
I thought it was infinity.
It's gotta be negative.
Okay.
Okay, it's gotta be
I
negative.
was so close.
If you remember your quadrants, that is the negative quadrant, by the way.
Yep.
Okay, so it's not the dot in the middle.
Nope.
It's the line.
Yep.
Just the line.
Yep.
Okay.
I circle the arrows, guys, and do top and bottom.
A lot of you had positive infinity for the top, but don't stop at the dot. Make sure you're going all the way down to the bottom of the graph. So this is what, and there are no numbers, so I'm not going to change my signs. This is what my range would look like. Okay.
I was top infinity.
How is the top infinity?
Yeah.
Here's the top of my graph, but my graph, it's kind of hard to tell, and this is why Schoology will be easier. My line's gonna actually keep going up. And so as it slowly goes up, the Y values are getting bigger, and it's just gonna keep going to infinity.
Okay.
This graph is poorly drawn, and I am sorry. Hopefully it will be easier on Schoology.
Okay.
All right, so the last thing that we are gonna talk about is how to tell if these graphs are a function. And here's our last vocab word. So the vertical line test or VLT. Okay, this is going to be our last definition. A vertical line,
Bruh.
which maybe draw a vertical line. Okay, make sure you're going up and down for me. A vertical line can only pass through the graph one time. So we're gonna go back and look at our graphs and tell whether they are a function or not. But here's my definition. Okay, we're just gonna be drawing lots of vertical lines. So I'm gonna start with this graph, okay? If I draw a vertical line through this graph, how many times did I cross the line?
2.
Okay, we crossed it here and we crossed it here. This is not a function. So maybe just over on the side, not a function, fails vertical line test. Okay, we drew a vertical line, it crossed twice. This is not a function.
So it has to go through the dot one time.
It has to go through any part of the line one time.
Okay.
So we'll do another one. So like on this graph, if I draw a vertical line, how many times did I cross it?
1.
Once. I only crossed it here. If I drew a vertical line,
So it's a function.
yep, so this is a function. So I'm gonna write that over on the side. Function. It passes the vertical line test. Okay. So I'm going to go back to some of the other graphs that we did earlier. On example 1, if we draw a vertical line through the graph, each time, how many times do we cross the graph? Just the one time.
1.
Yep.
So it is a function.
Yep. So this is a function, number 1 is, because it passes the vertical line test.
No.
And guys, be lazy. I won't say that very often, but be lazy and just anytime it's a graph, use the VLT as your explanation.
Okay.
Example 2, if we draw a vertical line, how many times do we cross through the graph?
2.
1 time.
What?
2.
Wait. 2. I'm just gonna say.
Okay, we cross through the graph twice. That's not allowed. So number 2, this would not be a function because it
I got that in
fails the
there right,
vertical
too.
line test. What?
I'm confused.
When
I got that in there right, but I didn't know.
Yeah.
What's confusing? For who's confused?
Like, for example number 1, isn't it already passing through the graphs? I mean, the graph?
So we are putting in vertical lines. So you are drawing new vertical lines in.
Don't consider the y-axis a vertical line.
Oh,
Yeah, this does not count. This does not count. This does not count. You've got to
Wait, why?
line in.
Wait, why did you draw the other lines again?
Yeah. What?
Like these lines?
Mm-hmm.
Yeah. Why'd you draw those?
Because I felt like drawing 3 of them. So the vertical line test, I've got to draw vertical lines in. And
Oh.
see how many times it
Alright.
crosses through the graph.
That
so
makes
with
sense.
example number 5,
Like,
it is not a function because it passes through the x-axis, or
How many times does it cross our graph?
once.
It crossed here,
Twice.
crossed here.
Oh,
Because we're looking at the original line that was drawn.
okay.
Heinz is coming too, right? Okay. So here's the deal, guys. Okay, these are your notes for today. Use them, keep them out. And today I want you guys staying on Zoom. That way you can ask questions as you're going through Schoology. Let me show you what I need you accomplishing for the rest of class. Okay. So you'll go to this week's folder. And today's the 16th. You guys won't see this yet though. He's fine. So here are the instructions. Okay, this is gonna be your homework, practicing continuous functions. And then I want you to submit a picture of your notes for me again. So you're done with the notes. There's no video to have to watch. I'll post this video at the end of the day. So if you need to go back to hear me explain it, do it again. Here's your homework, and then you're taking a picture of your notes for me.
The notes we just did.
Yep, so use these notes and take a picture of them and submit them for me.
Okay.
So I will publish today's folder. That way you guys can get into it.
So, do you know how many questions are on there?
Maybe 10.